The following content is created by Dr. Dravitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. My name is Dr. Dravitech. Welcome back to my YouTube channel. And in this video, we're going to be talking about Laplace transforms, multiplying by t or t to the power of n. Remember that all of these proofs that I've been doing, they lead us to solving problems without going back to the integral definition of Laplace transform. So what we're going to do is, to solve for this, first, let's remember that you have to subscribe to this YouTube channel, share this video to your friends, and then hit the subscribe button. I think I've said that already. So let's start. First, what is Laplace transform? So the Laplace transform of a function f of t is the integral from 0 to infinity of f of t e to negative st dt, and this will give us f of s. So this is what the Laplace transform of f of t is. But currently, we need something different. What if the function is multiplied by t? So we're having something like this. The Laplace transform, instead of f of t, we're having t f of t. That's what we're having. So this is integral from 0 to infinity. The f of t is multiplied by t. So this is t f of t e to negative st dt. How do we solve something like this? All right. So here's what we're going to do. Here's what we are going to do. Now let me write this back. I'm going to write this very portion back. So we have the integral from 0 to infinity of f of t e to negative st dt equal f of s. I'm going to write this back. Now if you look at the thing we're looking for, well, we need the t to multiply the f of t. So is there a way I can produce t? This is where t is. Is there a way I can produce t to come multiply this? Yes, there is a way. Because I remember that if I have e to negative st, so if I have e to negative st, and I am to differentiate with respect to s, with respect to what? S. What's going to happen here is, I'm going to say, differentiate this with respect to s. This will give us minus t. Yep, it's going to give you minus t. Because the s here is raised to the power of 1. So when you do your 1 minus 1, when you apply the laws of differentiation here, the t is a constant multiple, and then this s will then give us 1 when we differentiate. So this will become minus t e to negative st when we differentiate. So this means if I have something like this, it means my t can come outside. All I have to do is to differentiate both sides with respect to s. So this will become d ds integral from 0 to infinity of f of t e to negative st dt equal d ds of f of s. Yep, I can do this. Math is sweet. All right. Now, integration and differentiation can actually be flipped. So I can actually flip this. So I want to differentiate first before integrating. Because the way it is right now, I have to integrate first. But what I need is for me to differentiate first. So I'm going to take the derivative inside. So this will be the integral from 0 to infinity. Then d ds is going to be inside. Why do I keep just... d ds will be inside. Then f of t e to negative st dt. So this is what we have. Equal to d ds of f of s. All right. Now, I need to differentiate with respect to s. This ft is a constant, so let me just bring it in front because I am doing my derivative with respect to s. The f of t has no s in it. This is where my s is. So this will be the integral from 0 to infinity, f of t, then, let me kind of put this in a fancy bracket, d ds of e to negative st, and then my dt is outside because that's what the integral needs. Then equal to d ds of f of s. Beautiful. So this is what we have. Okay. Now, if I were to differentiate this, I've already shown you that this is what you're going to be getting when you differentiate this. So this will be the integral from 0 to infinity f of t. Let me put a dot there. So dot, when you differentiate this, this is what you're going to be having. So this is minus t e to negative st. That's what this bracket will give to you. And then you put your dt equal to d ds f of s. All right, so this is what we have. Okay, the minus can come outside. So this will become negative integral from 0 to infinity. Now, I want the t to come in front, just the way it is here. So I want the t to just come in front. It's a multiple, so it almost can go anywhere. So this will be t f of t. The one will be left here. Remember, I've removed the minus. I've taken the t to the front. So what's remaining is e to negative st dt. And this will equal d ds of f of s. All right, we're almost there. Almost there. Now, what I'm concerned about is this expression with no negative in front. There shouldn't be a minus in front. So I'm going to take the negative to this very side. So this will be the integral from 0 to infinity t f of t e to negative st dt. Now the minus can come in front. So this will be minus d ds f of s. Yep, I can do this. And with this, we've gotten the Laplace transform because this is exactly this. So we've gotten the Laplace transform of t f of t. So this will give us negative d ds f of s. And with that, we've derived, I think I want to use a red marker for that. So with this, we have differentiated, and then we now have our value. So this is going to become our Laplace transform when t multiplies. But then, this is just t to the power of 1. This is just t to the power of 1. What if it was t squared? What if it was t cubed? What if it was t to the power of maybe 7 or something? What do we then do? And here's the thing. Since the Laplace transform of t f of t is equal negative d ds f of s, what this basically means is, if I have the Laplace transform of t to the power of n, so this means my f of t will become negative. You know, there's a 1 here, invisible 1. So this is negative 1 to the power of n. Then that would also tell on how many times we need to differentiate. So this would be dn, dsn, and then f of s. What this is basically saying is, if we have 2, we have to differentiate twice. If we have 3, we have to differentiate 3 times. And that's just what it means. It's actually an easy one. That's just what it means. So let's take a few examples on this. Just a few examples. Now remember, every single thing we're doing, you have to practice them so they stick with you. Because when we get into inverse transform, we're very close to inverse transform. When we get there, you'll be able to understand what's going on. Okay, so the examples. So first, we have the Laplace transform of t sine 5t. So this is what we have. Okay, now for this one, the first thing I want to find is f of s. I want to know what f of s would be. So remember that this will be my f of t. So to get the Laplace transform of sine 5t, this will become 5 divided by s squared plus 5 squared. So this will then become 5 divided by s squared plus 25. Because the first thing you would do is to find the derivative. Why do I keep, oh no. Is to find the Laplace transform of sine 5t. Now this is t to the power of 1. This is t to the power of 1. So what this means is the Laplace transform of t to the power of 1 sine 5t will become minus 1 to the power of 1, minus 1 to the power of 1, sine, instead of this sine 5t, what we have here is, I'm going to write d1, then ds1, which is not really necessary. I'm just writing it. And then f of s is this, because this is our f of s. So that's 5 divided by s squared plus 25. Yeah, I know it's kind of weird, but you'll understand soon. So this will become minus 1, so that's just negative, d ds of 5 divided by s squared plus 25. So this is what we have. Now, how do we differentiate this very expression? Because we have to differentiate. Now, we can differentiate using quotient rule. We can also differentiate using the reciprocal rule. There's something called reciprocal rule in differentiation. Now, remember, for you to get to this level, it means you've done differentiation before. So I'm going to be applying quotient rule here. So remember that if you have d ds of uv, that's u over v because it's a quotient. This will become v du ds plus u dv dx. That's what we have. So in this case, our numerator is u, so this is u over v. So I'll say this is minus, and I'm going to start. I'm going to say v, this is quotient rule, sorry. So this has to be minus and then over v squared. Sorry, the previous one I wrote before was product rule. So our v in this case is s squared plus 25. So we're going to multiply that by du. If u is 5, du is going to be 0. Okay, and then we have minus. It says u, so I'm going to write u, which is 5. And then dv. If I'm to differentiate this, I'm just going to be having 2s. Because the 25 will give us 0 when we differentiate. So when you differentiate s squared, you get 2s. Divided by, the division is by v squared. So this will be s squared plus 25 all squared. Alright, now this will become negative. Everything here will be 0. So this will become minus 10s divided by s squared plus 25 all squared. Now the minus will take care of the minus, so this will just be 10s divided by s squared plus 25 all squared. So that's what the Laplace transform of that expression is going to become. Yeah, it's a little bit tedious. It's a little bit tedious. So this is what it's going to become. Let's take a look at another example. So we have the Laplace transform of, let's say, t squared. Yep. So we have t squared. Then let's say we have cos 2t. Cos 2t. Okay. Now the first thing is to find f of s. So that is going to be the Laplace transform of cos 2t. Now in this case, cos, this will become s divided by s squared minus 2 squared. I've done this in a video before, so this is what you're going to be having. So this will be s divided by s squared minus 4. So this is what we have. Now, we have the Laplace transform of t to the power of 2 multiplying this. So I'm multiplying by t squared. Now, the Laplace transform of t squared cos 2t will become minus 1 to the power of 2 d squared by ds squared of our f of s, because this is our f of s. So that's s divided by s squared minus 4. It's going to be a lot. It's going to be a lot. But let's see what it's going to become. Now, minus 1 squared is positive. So that's going to be positive 1. So what we have left is this. So I'm going to write this in another way. So this will be d ds by d ds of s divided by s squared minus 4. That's what it means by differentiating twice. So we're going to let's differentiate this one first using this. I'm going to be a little bit fast in this case. So this will be d ds of, now let's differentiate this one. So it says v will come first. Remember that the numerator is u, denominator is v. So v in this case is s squared minus 4. So that's s squared minus 4 bracket du ds. So our u is s. When you differentiate, you're going to get 1. And then minus, it says we're going to write u. So u in this case is s. And then dv dx. We have s squared minus 4 for v. So if we differentiate v, we're going to just have 2s. We're going to be having 2s. Then this will be divided by s squared minus 4 to the power of 2. All right, so this will be d ds into, now when you times this by 1, you basically get same thing. So that will be s squared minus 4. When these two things multiply, this will be minus 2s squared. And then divided by, leave this guy like this, that's s squared minus 4 squared. That's beautiful anyways. Okay, so this will be d ds. Now, s squared minus 2s squared is minus s squared. And then minus 4 divided by s squared minus 4 squared. Okay, so this is what we have. Okay, hold on. All right, so this is what we have. Now, to kind of make life easy for me, negative, the minus sign is common, so I can bring out minus. So this will be minus d ds. Now, if I'm bringing out the negative sign here, this will just become s squared plus 4. Then divided by s squared minus 4 squared. Okay, now let's differentiate this again. This is a lot. Let's differentiate this again. So this will be minus. Now it says that v must go first. So v in this case is s squared minus 4 all squared. So this is what we have. Then I'm going to multiply by du. So my u is the guy at the top because this is u and this is v. So my u is the guy at the top. So when I differentiate this, I'm just going to be getting 2s. Just going to be getting 2s. Then minus says minus u. So I'm going to be writing u, which is s squared plus 4. And then dv ds, that's going to be a crazy one. Dv ds. So we're to differentiate this. But if we're to differentiate this, we're going to be using chain rule in this case. So I'm going to say this is 2 with times this. So this will be 2 into s squared minus 4. Then 2 minus 1 is 1. Then I'll say times again. Differentiate the bracket. You're going to have 2s. That's why I said you must be very good with differentiation before doing Laplace transform. All right. Then divide this by, we must square our denominator. So this will be s squared minus 4 all to the power of 4. Remember previously there was a 2. So if you should square it again, that will make it going to be a 4. Okay. That's a whole bunch of stuff. All right. So I am about to do something. It's not going to be shocking. Just stay with me. Okay. So this is a minus. Now if you look at the numerator, 2s is common on both sides. 2s is common on both sides. And then s squared minus 4 is also common. So I want to bring it out. So this will be minus 2s bracket s squared minus 4. Then I'm going to open up a bracket. So I'm going to put bracket. Now, for the top only, 2s is out. So I'm going to cancel out 2s. Now, this is s squared minus 4 squared. But the one I brought out is just s squared minus 4. So this means that s squared minus 4 will still be remaining. Remember, I am factorizing. So I brought out one portion of this bracket out. So it means another one will still be remaining inside. And then minus. Now, this, I did not bring this out, so this is still going to remain. S squared plus 4 will still remain. And then this 2 here will still remain. So this is times 2. It's still going to remain. But the s squared minus 4, it's out already. The 2s is out already, so that's not going to come out. Our denominator is going to stay the same. S squared minus 4 squared. Now, this will become minus 2s bracket s squared minus 4. And then for our top, for the top here, this will be s squared minus 4. Then when we times here, minus 2 times s is minus 2s squared. Minus 2 times 4 will give minus 8. Then this will be divided by, oh, sorry, this was to the power of 4. This is to the power of 4. All right. So this is s squared minus 4 to the power of 4. All right. Okay. So this will be minus 2s into s squared minus 4. And then, what I'm going to be having here, s squared minus 2s squared is going to be minus s squared. And then minus 4 minus 8 It's going to be minus 12 divided by s squared minus 4 to the power of 4. Okay, now if you look at this, minus is common here, right? So I can bring out the minus again. So when the minus comes outside, this will make this negative sign here become plus. So let's be a little bit fast. I don't have any more space. So this will be 2s into s squared minus 4. Then we have s squared plus 12 into s squared minus 4 to the power of 4. But we can cancel out because these two things are actually the same. We can cancel out. So this is to the power of 1 and this to the power of 4. So it means when they cancel out, 3 portions of this will still be remaining. So this will be 2s. This one is common, remember. So this is 2s bracket s squared plus 12 divided by s squared minus 4 all to the power of 3. And this will become the answer to the equation. That's a beautiful one. All right, so this is how we multiply by t and t to the power of n in Laplace transform. So remember to like this video, leave a comment. If you like this video, leave a comment, and then hit the subscribe button. I'm going to see you in the next video. Bye.